Alright, here's your Algebra 2 quiz on vectoring. Make sure you review this because none of us did particularly well. Here's problem number 1, x squared plus 2x minus xy minus 2y. Now we do want to solve this one by grouping because it's got 4 terms, and 4 terms is an indicator that, hey, give it a shot by grouping. Okay. Now when we group it, we do have to be very careful. Okay, we want to group the first two together, and we want to group the second two together, but the second two, notice that negative is with the xy, and negative with the 2y. So when we group it, we're going to do it like this and put a plus sign in between there. So we're adding the negative xy and the negative 2y. Okay, I'm going to spread that out so we can see it a little bit better. So it looks like this. Okay, a good indicator again was that 4 terms that told us try it by regrouping. Now we look for a GCF. Some of us are having a hard time with the GCF. What you want to do is look for what they're both divisible by, in this case x for the first ones, and you write that out front, and then you divide them both by that x. Okay, so if we redistribute that x, we'd get back where we started at. The next one, they have a y in common, but we're going to take out a negative y because that's going to give us a positive x and a positive 2. And by doing that, we now have a common factor for these two terms, x plus 2. So we're going to take that x plus 2 and we're going to pull it out front of each term. So I bring x plus 2 out. So I've brought this out front, and that leaves me in this entire term with an x. So right now this little expression I've written is x plus 2 times x, which is what we started with. Then I've got this plus a negative y times x plus 2. So I pull this x plus 2 out front, right out here, and that gives me a negative y or plus a negative y. And so my final answer is x plus 2 times x minus y. And you could check this really quickly. It checks rather simply. If you were to distribute x, or what it says is take x times this, so that's x times x minus y, and 2 times this, so it'd be plus 2 times x minus y. Okay? And that is exactly what we have right here, x times x plus 2. I should have written that the other way. Okay, I'm going to erase this really quick. I should have written it the other way as an answer. So, and it doesn't matter, it's still equal, but then trying to prove it didn't work out so well. So instead of writing it this way, I'm going to write it as x minus y times x plus 2. It's the same thing, but now it fits the format of the answer. Distribute the x, you take x times all that, you get x times x plus 2. And then distribute the negative y, and you get negative y times x plus 2. And so that is up here that I circled in red what we started with. So our final answer for this, by doing this grouping by terms, is x plus 2 times x minus y. Our big clue to do this is this fact up here, that we had 4 terms to start with. Let's go to a new page here, and we'll look at problem number 2. Number 2, a lot of people had a difficult time with. We've got 4x to the 6 minus 4x squared. Again, we always start with GCF, everybody, and that's what a lot of us forgot. In this case, I thought the GCF would be fairly easy because we can see they both have a 4 in common, and they both have this x squared in them. I know this doesn't look like an x squared, but you can think of this as 4 times x squared times x to the 4th, because that would be x times x, and then 4 more x's multiplied together. So they do have at least a 4x squared in common. So what we're going to do is take that 4x squared out. That leaves us with an x squared minus a 1, because 4x squared times 1 is 4x squared. Now this, we aren't quite done yet, is a difference of two squares. Okay, we can think of that as an x squared minus a 1 squared. And we have a formula for that, which is just take what they've squared minus what they've squared, and take what they squared plus what they squared. So that is the complete factorization of the original polynomial. Problem number 3. 3 we did a nice job on, thank goodness. A lot of you changed your n's to two x's, which is fine. And so we're just going to unfoil this. There's no GCF because that's 11. And you just try all the possibilities. In this case, if I use a 6n and an n, and a 1 and a 2, then I'm just going to highlight what I'm looking for. First of all, 6n times n gives me the 6n squared, so that works. Then next, the 1 times 2 gives me a 2. And finally, I have to look at this product, which is 12n, and this product, which is 1n, and they have to add up to give me this thing in the middle, the negative 11n. And that's going to happen if the 12 is negative and the 1 is positive. So to get to be a negative 12n, I make the 2 negative and the 6n plus 1. And so my final answer, 6n plus 1 times the n minus 2. Problem number 4. We get 20x cubed plus 13x. I'm sorry, that was 20x squared plus 13x plus 2. I'm going to attack this trying to factor it into two binomials. Again, you play guess and check. These first terms have to give you 20 when you multiply. It could be 1 and 20, 2 and 10, 4 and 5. I'm going to try the 5x and the 4x. And then these terms back here, they have to multiply and give you a 2, so it's got to be a 1 and 2. I'm going to put my 2, let me change colors for a moment so you can see. Put my 2 here, my 1 there. This gives me an 8x when they're multiplied. This gives me a 5x. And 8x and 5x add up to 13x if they're both positive. So there's my final factorization, just playing guess and check, although it's a kind of a thoughtful guess and check. Next, problem number 5. Problem 5, we've got 64x cubed minus 27. Now, it's got two terms. We look for a GCF, there is none. Okay, GCF, CF. See if we can write this correctly. GCF is just 1. Okay, so we can't do anything with that. Then we notice it's got two terms, so it must be a special one. We notice the 3 up there on the x and the minus signs, so it's a difference of cubes. So let's see if we can figure out what the cubes are. That's a 4x that's been cubed, and 27 is a 3 that's been cubed. And now you have to memorize that formula. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So we're just going to plug in for a and b. So for us, think of it as a 4x is our a, and a 3 is our b. We're going to plug those things into the formula. So we go a minus b, 4x minus 3. Then it says, take the a value and square it. Well, we square 4x, that's 16x squared. It says, add a times b. 3 times 4 is 12, and we get an x. And it says, square the b. So we take 3 and we square it. And we're done. Next one, problem number 6. And let's see what we got. Problem 6. 81 x to the 4th minus 16. So we first look for a GCF. It's just 1. Done. Then we notice it's got two terms. Then we look again and we say, well, hold it. It's not cubes because x to the 4th. So the only one it can be is difference of squares. That's it. So we try and figure out, what if they squared to get 81x to the fourth, and that is a 9x squared that's been squared. And that is a 4 that's been squared to get a 16. See, it's a difference right there of 2 squares. And we have our formula for it that says a squared minus b squared is a minus b, a plus b. For us, a is 9x squared, and b is equal to 4. We just plug those in. We go a minus b, and we go a plus b. Oops, not a. It is a plus b in the formula, but for us it's 9x squared plus 4. You always check your answer then to see if we can factor further, and we should notice we end up with another difference of 2 squares. That's a 3x that's squared minus a 2 that's squared. There's the first one. Here's the second one. That's a sum of 2 squares. We can't factor that. We have no formula for it. In fact, to factor it, you'd have to use imaginary numbers. So we'll focus on this. A is 3x and b is 2. So it's a minus b, a plus b, and then our third factor will be this 9x squared plus 4, which is the prime one. So this would be the complete factorization for number 6. Problem number 7. Problem 7. We've got x cubed plus 3x squared minus 54x. We check for a GCF, or same thing we always do. Oh, yep, there is one. They all have an x in them. So we pull that x out. Then we look at what's left over. We've got an x on the outside. That's 3 terms. We try to unfoil it. 54 is 9 times 6. We make this one positive, this one negative. And by doing that, we get 9x here. We get negative 6x there. And they add up to 3x. Okay, let's go to problem number 8. Problem 8. Last one. We've got 7a squared. Oops, let's erase that and use the right pen. Use this pen. Problem number 8. We've got 7a squared x minus 6a squared minus 7x plus 6. It's very similar to the very first problem we did. We'll group this. And we're going to group this together, and we're going to have a sign in there, so these things are a plus each other. Okay? And then in the first term, you can see here the first grouping, they both have an a squared in them, so we pull that a squared out. Left with 7x minus 6. The second one, we're going to pull out a negative 1. We already got that plus sign between them, so we pull out a negative 1. We've got 7x minus 6. And there we can see are the common factors. So we pull that common factor out front. And then we are left with, let's see if we can get a little bit different color here. There we go. We're left with this a squared and this negative 1, and so we write those as an a squared plus negative 1, or just minus 1. And that's it. That's all we can do. Oh, no, it's not. We can go one more step. 7x minus 6, we have a difference of squares here. A minus 1 times a plus 1. So there is our best answer. Use that one. And that's it. Don't forget to go to algebra practice or algebra practice tests on the website. You can go to this section. This is section 6.4. And you take some practice quizzes on it. You want to practice the factoring questions.